This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 10 problems from the March 2025 Digital SAT Math section. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I get started on this March 2025 Digital SAT Math worksheet and video problem set number 2, please keep the following things in mind. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there will be a link to the PDF file which has these problems in them in both the description of the video and also in a pinned comment. Third, a lot of these questions are going to be done as free response or student-produced response. However, you may have received them as a multiple choice question, on your official exam. So just keep in mind there may be additional solution methods that I'm not demonstrating here because I am not solving them as a multiple choice question, since I'm only doing them as a free response. And the fourth thing is, these are all self-reported questions, so I've tried to gather as much information about them as possible and make them as easy to understand as possible. But there might be little details in a question I have here which is different than maybe one that you received on your specific test. So just keep that in mind. I've tried to make them as workable, and as understandable as possible, but there might be slight variations again. Obviously, different numbers are a possibility, but there might be other slight variations that you see compared to a question that you got on an official exam. All right, so with all that being said, let's go ahead and get started with problem number 1, again from this March 2025 Digital SAT Math problem set number 2. So here you have a problem dealing with a relationship between M and Q and R, and then also a separate relationship between Q and R, and they want to know the value of M. Now, for the calculations, I'm just actually going to go straight to Desmos and do everything in there rather than bothering to write them out by hand. But of course, you could do that as well. So I'm going to start with the second statement where it says Q is 30% of Q plus R. So I'm just going to do a regression for that and basically just say Q is 30% of, and then put in parentheses, Q plus R. Now, I have to still define what Q is, otherwise it just gives me 0 and 0. Okay, so I do this and I get R is equal to 3836. So now I have Q, now I have R, now I can go ahead and solve for M. Now, one other thing just to note, I saw other variations of this problem that gave the value of R to begin with. So the process here would be identical. It's just in this line, you'd just be defining R equals whatever, and then it would give you what Q is. So now we can go to the first part of this problem where it tells us M is 20% of, and then we have M plus Q plus R. Now, when we work this out, let's see here. Why is this not giving me the answer that matches my notes? This is giving... Oh, here's the problem. Okay. The problem is it's actually, it looks like it's not carrying through, and this is something to be careful with. So the value of Q is already defined here. All right. But R is not defined. R is technically a constant which is based off this equation. So if you're going to do it this way, you actually either have to type the number for R, or we have to take a second, basically another step. Like, let's just move this up here. We actually have to define the value for R it gave us in step 1. So I do this. So now, notice, okay, this is the correct answer that I'm looking for. 1370. And one thing to note is that, let's see, Q we can't change. Okay, R is going to be fixed. So yeah, so this is pretty much it. We're not going to move the slider at all. We don't need to do that to check anything. I will just show you basically, I won't go through all the work, but here's what the actual equations would look like if you hand wrote them out. So the first one is essentially 1644 equals 0.3 times 1644 plus R. And again, you go ahead and you solve this and you get R equals 3836. And then the second one is just M equals 0.2 times M, and then for Q, you could fill in the 1644. For R, you could fill in 3836. And then you go ahead, distribute the 0.2, move the m terms over. Eventually, you should get 0.8m equals 1096, or m equals 1370. So again, these are the basic equations. I'm just kind of skipping the work because I just do it all in Desmos. But the correct answer, based on these numbers, is 1370. Of course, if you had different values for the percentages, or for Q to begin with, or if you were given R to begin with, you would get a different answer for m, but the process is still the same. All right, let's talk about number 2 next. Here you have an exponential function. It's basically decreasing, and it says that f of n is p% less than f of n minus 1. So what this is basically saying is you plug in some value, and essentially the one before it, or in other words, like one less than that value. If you started there and went to this recent one, it went down by p%. That's really what's going on. So here's the theoretical way you could solve this, and then I'll show you, actual example with numbers, and I'll just do it in Desmos. So the theoretical way says, okay, we want to find something % less than this. So this is the original, this is the new. So the original says you plug in n minus 1 for the x here, and that's going to go in the first spot, and it's also going to go in the bottom. I'm basically doing the % difference, % less than, % more than formula, where the original goes here and on the bottom, and then I'm subtracting the new. The new one is the f of n one, so meaning 500 times 0.25 to the n. All right, so this looks like a giant mess, but it's actually not going to be that bad, because what you can do is, first of all, the 500 can just be canceled out. Like you could factor a 500 out of the top, and then it cancels with the 500 at the bottom. So we can just get rid of that and make things simpler. All right, then you can split this up into two fractions. The first one, notice it's going to be the same exact thing over itself, and the second one is going to be 0.25 to the n over 0.25 to the n minus 1. Now, this just becomes 1. This, if you follow the rules of exponents, because these have the same base, you subtract them, right? So it's n minus 1. N minus n plus 1. N minus n cancels. So this whole thing just becomes 0.25 to the first, or just 0.25. 1 minus 0.25 is just 0.75. Now that's the decimal value for p, but they want p%. So you have to multiply this by 100%. The correct answer for p that you would fill in is 75, because it's 75%. But again, of course, you just type 75. You don't put the actual % sign. But that's the correct answer. Here is how you could do picking numbers in Desmos and just do the whole thing. Let me just scroll down here a little bit. All right. So first I'm going to define my function. Okay. So you just need to compare two numbers that are separated by 1. So like I'm going to do f of 2 and f of 1. Okay? And basically what I'm saying is I'm letting n equal 2. So if you want to think about it that way, we could actually do this. Okay? And then what we could do is, again, it's going to be f of n minus 1 minus f of n. That's the old value minus the new value. And then the whole thing is divided by f of n minus 1. But again, this is the decimal, so to get the percentage, we need to multiply by 100. And so right there is our answer. It's 75%. And what you will notice is it stays constant as I move this slider, right? It doesn't matter. No matter what value I choose, it's still 75% less than the value before it. So that's how you could do the entire problem in Desmos. All right, let's look at number 3 next. This one has an absolute value function in it. And they want to know what is the product of f of 17a and times f of 7a. So first, I'm going to go straight to Desmos, so just do it in there, and then I'll talk a little bit about the theory of how this happens. So I'm going to define my function, absolute value of x divided by a minus 16. Now for a, I just need to pick a negative number, so I'll just put in, whatever, -2. Okay, So what's the product of f of 17a times f of 7a? Well, it's 759. That's it. That's the correct answer. You don't need to do any more work than that. However, I will just mention briefly and show you if you want to do this by hand, so you plug in like 17a here and you got it over a minus 16, blah blah blah, and then here we have 7a, erase that. Absolute value 7a over a minus 16. Okay. Basically what's happening here is, since a is a negative number, like on the top, the absolute value of 17a just becomes 17a, and the same thing for the 7 as well. But what you have to remember, what you have to keep in mind, is that a is a negative number. So like, if this a was, say, negative 2, up here it's really a positive 2, but down here you put it as a negative 2. You know, up here it's a positive 2, up here, down here it's a negative 2. So what ends up happening is, you know, the 2's cancel out, but it makes this 17 negative, for example. And the same thing over here. The 2's cancel out, but it makes the 7 negative. And so now you could just do negative 33 times negative 23, and that should be 759. So that's just basically showing, you know, really what's happening with this problem if, you know, you're to write it out and do it by hand. Next up, we have basically a radical function with a quadratic expression underneath it. We're given 2 points it passes through, and we want to know, basically, essentially m here is an x-intercept, a 0, a root, whatever you want to call it. We want to know what's the greatest, you know, possible value of that. Notice one of these right here. This is already an x-intercept, a 0, a root. So the question is there going to be another one that's greater than 2, or is it going to be less than 2? And if it is, then this would just be our answer. So you can do this one by hand. I will briefly go through it. I'm not going to go through all the work because it is so much faster, quicker, and easier in Desmos. But first I'll just mention a couple things. First of all, if you notice at this point here, if you set the left side equal to 370 and then plug in 0 for x, underneath the radical, these two terms drop out, so you just get this. So therefore, the c value has to equal 370. Then to find b, you could go ahead and you could just plug in this point. So in other words, 0 equals root, negative, caught together with the radical. 2 squared plus 2 times b plus 370. And then this you can just go ahead and technically you could first square both sides and it's just 0. And then this is 374 plus 2b. So b is going to equal negative 187. So now you have the full equation. X squared, get rid of this, minus 187 plus 370. Minus 27x, excuse me, plus 370 all under the radical. Okay, so now you just have to find the zeros. Now if you wanted to, you could take this and you could factor it. Again, I'm not going to show all the work because, I mean, I've already worked it out and know what the answer is. It's so much easier to do this in Desmos. But it's going to factor as x minus 2, x minus 185. And then your x's, your two zeros are 2 and 185. So what's the greatest possible value of m? Well, it's just this right here, 185. Now, a couple things to mention in Desmos. So if you try to do this using regression, you're going to see something unusual. So first, okay, here are 2 points that we have. So if you just try to type it exactly as it is, you're going to run into a problem, and it's because of the square root. Okay, so if you notice here, these are not the correct values. In other words, for B and C. You know, when I worked it up by hand, I got negative 187 and I got 370 for C. I don't know exactly why it's doing this, and you can even see let's see, the 2, 0 is right here. Notice it goes through 2, 0, but my other point, my 0, negative root 370, it doesn't go through that. This point, that's the point right here in green, and the graph is clearly not going through it. And also notice the r squared value is not 1. That tells me that there's error. It's not, 100% accurate. So something's going on that this is not, that this is not correct. The only way I found to go around this was if I squared both sides. So that means basically get rid of actually let me see. I think when I first did it I got rid of the square root expression. No, that didn't do it. So yeah, I think I have to do that. So let me, there we go. Okay. Okay, except this, see, so notice here, it's giving me the right C value, but it's not giving me the correct. See, yeah, technically, what you have to do, this is the way you have to, basically you have to square both sides, and that will get rid of the negative here that's in front of the radical. But that's fine, because notice it gives you the correct values for B and C. It gives you negative 187 and it gives you 370. So now what you would have to do though, because notice there's no graph on the screen, okay? Now what you would have to do is you would have to go back and basically retype the equation in its given form, which is with the square root. Actually, we should be able to type plus bx plus c. Okay, yeah. Now it's giving me the actual graph. So now the question is, what's the greatest zero or intercept? Well, it's not 2. It's over here at 185. So that's that's basically your correct answer. And this is kind of the approach or the strategy that you have to use in Desmos, because the square root is basically messing up the regression. Now, I will also mention, if you did the first part by hand and you got B and C, of course, then once you got to that point, right, then you just go to Desmos and you type in x squared minus 187x plus 370, just ignoring the square root. We're only concerned with the part underneath it. And then, you got to scroll, and then you can see right here. Here are my 2 zeros. 2 we already know about. 185 is the one we're looking for. Okay? So you could obviously do this part right here, this second half of the problem in Desmos as well. Next up, we have question number 5. And this is actually a fairly tricky question, because you are given a function here and you're told it's going to be factored into some form there, and a, b, and c are obviously just coefficients, constants, numbers, integers, and they want to know what the value of a times b plus c is. So the reason that this is a tricky problem is because there are multiple ways that you can start the factoring. In other words, so if you look at this in terms of a is going to be the common factor that you pull out of all terms, right? So you could technically just do a equals 1 and just leave it as it is. You could also do a equals 2. You could do a equals 5, or you could do a equals 10. You can't go anything above that, because once you pull out a 10, the 320 turns into 32, and then you can't go any lower. You can't leave a number smaller than that, because then you couldn't factor it and have 32 as one of the last numbers in one of the parentheses. Okay? So the thing is, though, then if you're looking to factor it, so you've got basically the original problem, you've got the 2 out front here, and then you're going to have 20 and 120 and 160, and then you have a 5 out here, and you're going to have 8 And let me just make sure I get this correct. 48 x squared plus 64. And if you factor 10 out, you have 4, 24, and 32. Okay. Here's where the issue or the problem comes. Technically, only one of these can actually be factored correctly into this form such that when you multiply it out, it meets the original problem. And so just to save time, in essence here, I'm going to show you, I'm going to basically demonstrate this in Desmos. So, all right, so I have the original, right? 40x to the fourth plus 240x squared plus 320. So if I'm going to factor it into this format, okay, first of all, a is 1, that's out front, okay, and then I have to have an x squared here. Now, 320, it has to be split up into 32 and 10, meaning b has to be 10 because the 10 has to multiply by the 32 in the other parentheses to make 320. Similarly, you have to put a 40 here, okay, and that's going to be c, because 40x squared times the x, just the 1x squared in the first parenthesis has to make the 40x to the fourth. All right, so here's the thing, and I'm going to type the original. Okay, so I'm going to type the original before the factoring. Here's the problem, though. I'm going to zoom out. Okay, so if you zoom in here, you technically will see these two graphs are not the same. Like, they do not overlap. This is the original, and this is how it would have to be factored given the constraints of the problem. So the point is, if you multiply this out, it doesn't equal the original expression. You basically get 400x squared plus 32x squared. You get 432x squared for the middle term, and that doesn't match. So you cannot factor a, or factor like the first option where a equals 1 into that form. And if you try to do it, I'll just try it for one more to show it doesn't work. I'm not going to show all three that don't work. But if you try to do it for the second one, so again, the original thing is going to be with the 2 out front. Okay, this. And now when we go to factor it, okay, we have the 2 out front here. Okay, it's going to be x squared and 20x squared to make 20x to the fourth. And 32 times 5 is what equals 160. So this has to be a 5 here. All right. So now again, if you notice, these two graphs, let me just zoom out and go down here till we get to where the vertex is. Zoom in a ways, they're pretty close, but they're not identical. They do not overlap. You can see there's two distinct colors, on the graph. And again, if you check the inner, multiplying the inner and the outer, 5 times 20 is 100. 32 times 1 is 32. 100 plus 32 x squared does not equal 120x squared. So the point is, these two are not equivalent. So if you pull out a 2, you cannot factor with the remaining expression into this form, okay, where you have a plus 32 and you have just a 1x squared in the front. The only one that works is going to be this one right here. Okay, and it's going to factor as 5x squared and then 8x squared. Just make sure I get this correct. And then it's going to be 32 and 2. And now if you check it, 8 times 2 is 16. 32 times 1 is 32. They add to make 48. That matches this right here. Okay, and we could go to Desmos and I could graph both of them just to show you that like this graph completely overlaps this one, but this is going to be the correct answer. Therefore, A is 5, B is 2, and C, just make sure I get, right here C is 8. So 5 times 2 plus 8, 5 times 10 equals 50. Now, the thing that is actually interesting or unusual about this is even with the other possibilities for A, I believe if you try to factor them out, like if you even if you try to factor them, even though it's not correct, the a, b, and c values are different, but this expression still ends up equaling 50. So even if you chose one of the other ones by mistake, like if you did this last one by mistake, it still technically ends up working out to 50. I don't know why they set it up like that. I don't know, why it works out like that, but in any case, I believe for the other three wrong answer choices that technically you can't factor any further, you still end up getting the same a times b plus c value. But in any case, the correct answer for this is 50. Next, let's look at question number 6. Here we have an equilateral triangle. You're told its perimeter is 796. So that means each side is actually 796 over 3, or if you want to divide it, I mean, I wouldn't recommend doing that. I guess you could, because it's still, in Desmos, would still give you the exact value, but it's approximately 265.3 repeating. But I'm just going to do everything with the fractions. Okay, so 796 over 3, 796 over 3, 796 over 3. Okay, its height is r root 3. What's the value of r? So when you take an equilateral triangle and you split it down the middle by drawing an altitude, it makes two 30, 60, 90 triangles. What you're going to do then, most likely easiest way to do this is using special right triangle properties. I'll talk about basic trig in a second. So this right here is r root 3. So what happens at the the base of the triangle down here, 796 root 3, it gets divided evenly in half because we have two congruent triangles. So that means that we're going to have 398 over 3 and 398 over 3 here. Now this side is across from the 30-degree angle, i.e. this is the short leg. So to get to the long leg, the leg which is across from the 60-degree angle, which is the height, we take this value and we multiply it by root 3. That's basically the special right triangle properties. So that is equal to the height, which we already know is r root 3. Therefore, what does r have to equal? Well, the root 3's cancel out, so r is just this number right here, 398 over 3. You could also report it as 132.6 if you truncate it, or 132.7 if you round it. So any of those three answers would be acceptable for this. Now, I will also show you, okay, if you wanted to do basic trig, essentially what you could do is, so maybe you would say like, okay, sine of 60 equals opposite, which is r root 3, over hypotenuse, 796 over 3. Let's see if we can do this one using regression. So sine of 60, first of all, I already noticed that I need to switch it to degrees from radians because that's not the proper degree value. Okay, and let's say I have r square root 3 divided by, I'm going to put in parentheses, 796 over 3. Yep. So notice right here, it gives me r, 132.6667. So this is an alternate way you could do it. Maybe you think this is quicker and easier. And then what I would do is I would type r and then click on this, and that gives me the equivalent fraction. So if you want to do it in fraction form, you could get it here, or you could again do 132.6, 132.7. All right, next, let's talk about question 7. This is a repeat question. This appeared last year, I want to say in May, possibly in June. Basically, you have a quadratic polynomial, i.e. graph is a parabola, and you're told that when f is 1, here's 1, let's say here's 4, here's 7. Okay, so when x is 1, the value is positive. When it's 4, it's negative, and when it's 7, it is positive. Okay. All right, I just realized, I forgot to mention, I'm going to have to change the wording on this. This will be fixed in the PDF. These a and b are supposed to be integer constants. They have to be integers. Otherwise, there's an infinite number of answers you could give. So that'll be fixed in the PDF. Basically, you could say a is going to be a number, so to get from here to here, it's got to cross between 1 and 4, and then it's got to go back and cross again between 4 and 7. So therefore, for a, you have two choices. It could be 2 or 3, because again, it has to be an integer. value. Same thing for b, it's got to be 5 or 6. So here you have all your possibilities. You got 2 and 5, which is 7. You have 2 and 6, which is 8. 3 and 5 is also 8. Or 3 and 6, which is 9. And you just add them together. So there's 3 different answers you could put in here. You just fill in 1, 7, or 8, or 9. And that's it. All right, let's look at number 8. So this one, you're given a table of values, and you're told that basically a line goes through these 3 points, and they want to know the way the question was reported is what's the equation of the line. If that's really what it was asking, it would have to be multiple choice. But if it asked for just the slope of the line, then it doesn't have to be. Then or if whatever it asks for k, like then it doesn't have to be multiple choice, obviously. But I'm just going to go ahead and find the equation and whatever, just do it as a free response. So there's a quick, easy way to do this and a much more difficult, longer way. The quick, easy way is to find the slope between these 2 points. Because if you do that, the k's will cancel out when you subtract the x values in the denominator of the slope formula. So you get 26 on the top, and k minus k cancels. 5 minus 8, negative 3. The slope of this line is negative 3, and also notice they give you the y-intercept, so you don't actually have to do any more work. It's y equals negative 26 thirds plus 4. This is our b value right here. So that's the equation line. It's negative 8 and 2/3 for the slope, negative 8.66666 repeating. Okay? So this is the quick, fastest, easiest way. An alternate way you could do this is you could technically set up 2 slope equations. If you wanted to solve for k, you could set up 2, but you don't have to do that, but you could set up 2 slope equations with both these 2 points and these 2. And so what it's going to look like is it's going to be for the top 2, negative 5 over k plus 8, and for the top and the bottom, it's going to be 21 over k plus 5. Now, when I tried to do this using Desmos, for regression, it was messing up and not giving me the correct answer. I'm guessing it's because it's the rational expression. So instead, basically what I did is I just cross-multiplied it. And now it does give you, this is the correct answer. It's negative 7.42308, blah, 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 blah. That adds a bunch of extra digits. 42308, dot, dot, dot. Okay. Then what you could do is you could technically basically take either one of these expressions and figure out the slope, and then just plug that in along with the y-intercept, which you already have. So what I mean by that is, if I just do negative 5 over k plus 8, okay, that's my slope. Again, negative 8 and blah, 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 or click this, negative 26 thirds. Okay, that matches. I would not, after you find k, I would not try to actually do linear regression in Desmos, because when I tried to do that, it became a giant pain, because because you want the exact k value, but you can't get the exact value because you can't type out all the digits. So you either have to type it by hand and leave off some of the digits, or I couldn't get it to recognize, it said the function is not defined in any region. When I tried to type this table of values and use the k that's coming from the regression statement right here, this regression statement, it wouldn't carry it through properly when I tried to do another regression with it. So therefore, I would not recommend that approach. I would just recommend doing this and getting the slope, and then again you could write just y equals mx plus b. All right, question number 9. This is another repeat question. This first appeared last year, I think in March, maybe in May. And so the trick to this one, first of all, this is it's technically not a quadratic, but it does look like a quadratic. It's the same thing where this variable is squared the amount, the degree that the middle one is. And so basically it's going to factor as z to the 9th times z to the 9th, and then plus something plus something. And we know that it factors because it has at least one real solution. And it tells you that this, this is an integer. So the way that you get the greatest possible value of b is basically you take the a value and you split it up as just the number times 1. So you put, say, 34 out here and like 1 here. And you do the same with the c value. And you split it up into 50 times 1. And you make sure you put the number, i.e. in this case the 50, such that it will multiply by the a value and the two ones will multiply together. That's how you get the maximum value for this problem. So it's going to be 34 times 50 plus 1 times 1, the inner and the outers, to get the, the middle term, which is going to be 1700 plus 1, it's 1701. That's what you would fill in for your answer to this problem, and it always works out such that it's basically a times c plus 1. That's essentially just the shortcut for like these types of problems for how it works. All right, last, let's look at a problem involving some similar triangles. Question number 10 here. So we have two right triangles. Here is, let's see, A, B, C. B is our right angle. And then we have a larger one, D, E, F. E is our right angle. That's given. Okay, every side in DEF is 2.7 times corresponding side length in ABC. So tan F is 9 over 40. So that means you could say the opposite side here is 9. Here's angle F. And the adjacent side is 40 from SOHCAHTOA. Tangent opposite over adjacent. Okay. The quickest, easiest way to do this is to note that since you have when you have similar triangles, the angles themselves are congruent. So angle C is congruent to angle F. What that means is the cosine of C will be the same value as the cosine of F. So what's the cosine of F? Well, cosine of F is just adjacent, which is 40 over the hypotenuse. Well, I don't know the hypotenuse, but I can use Pythagorean theorem to find it. 9 squared plus 40 squared equals c squared. This is an example where I think using regression Desmos is so much quicker and so much easier, because you can literally just type 9 squared plus 40 squared, then the tilde, c squared. Okay, so c, the hypotenuse, is 41. Therefore, cosine F is 40 over 41. That means cosine C is also 40 over 41, and that's our answer. So note, if you want to put it as a decimal, there's like multiple different ways you can put it. You could put 0.9756. That's 5 total spaces. You could put 0.976 if you round. You could put 0.975 if you truncate. So again, all of these would be considered correct as well. Now, an alternate approach to this, which is a little bit more work, takes a little bit longer, you could figure out the actual side lengths for ABC. So like, let's say you used Pythagorean theorem and you found this is 41, and then you notice, okay, every side in, like, basically DEF equals 2.7 ABC. So that means each side in ABC is smaller, and specifically the way you get it is you divide the 9, the 40, the 41 all by 2.7. So you could just go into Desmos, and you could just say, okay, 41 divided by 2.7. Well, it's whatever. 15.185, blah, blah, blah. And then you could also do 40 divided by 2.7. 14.81. Again, I'm going to use the exact values. I'm just writing these down as like, temporary things. 9 divided by 2.7. 3 1/3. 3.3 repeating. So once you have these, then you could say, all right, cosine C equals adjacent over hypotenuse. So notice, the adjacent is the 40 divided by 2.7. So I'm going to call this A, just for the adjacent, and the hypotenuse is the 41 divided by 2.7. So I'm going to call this the hypotenuse. So I'll just define this as H. Okay, and now I can say I know that cosine C is just equal to adjacent over hypotenuse. And notice I get the same decimal here, but because I defined A and H as the exact values, if I click this, it gives me the nice 40 over 41 if you want to enter it in fraction form. So this is just an alternate approach if you actually wanted to find the exact values for every side in ABC and then calculate cosine C from there. All right, I hope you enjoyed this video covering 10 more problems from the March 2025 Digital SAT Math section. If you have any questions or comments or alternate solution methods, of which I'm sure there are many out there, please do leave a comment below. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, as I mentioned, check out the videos to the other problem sets, from March 2025 as well. And lastly, if you're looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math, over 3.5 hours of tips, tricks, and practice problems to help you ace the Digital SAT Math section by using Desmos.